For years, analysts watched China's Air Force transform in silence, sleek fighters appearing out of nowhere, stealth prototypes tested at remote ranges, and satellites that quietly mapped the PLA's ambitions. Among these developments, one program has become a shorthand for China's leap toward strategic reach, the H-20, rumored to be a flying wing, stealth bomber capable of delivering both conventional and nuclear strikes at intercontinental ranges. The H-20 is framed in Beijing's strategic circles as the missing piece of a global air power puzzle. But beyond parades and official teasers lies a more complex picture. The H-20 is as much an industrial and doctrinal gamble as it is a boast of reach. In the next sections, we will explore why China pursued this design, what the aircraft appears to be able to do, the engineering and operational challenges that lie ahead, and what its arrival means for regional stability and global deterrence. This is not a tale of simple parity between two airplanes. It is a story about how states translate technology into strategy, and how rivals respond when that translation seems successful. China's pursuit of a long-range stealth bomber is rooted in a fundamental strategic calculation. To become a truly global power, you must be able to threaten important assets at distance, not merely control your near seas. For decades, China's military investments focused on area denial and anti-access capabilities, missiles that could hold carrier strike groups at risk, air defenses that could blunt foreign air power, and a rapidly expanding surface fleet. Those capabilities were designed to prevent intervention close to home. But deterrence by denial is different from strategic reach. A bomber that can fly from Chinese territory to strike bases, logistics hubs, or maritime rendezvous points adds options for coercion, signaling, and escalation control that are otherwise unavailable. Politically, the H-20 allows Beijing to demonstrate that its national defense is entering a new phase, one where it can both deny and project. Operationally, it forces potential adversaries to broaden defenses, stretching radar networks, interceptors, and logistics over far greater distances. Thus, the bomber is not merely an aircraft. It is a lever in a broader strategy aimed at shaping how others calculate risk and response. The decision to adopt a flying wing architecture for the H-20 is no accident. That planform reduces radar cross-section by removing vertical tails and smoothing reflective edges, enabling an approach profile that delays detection and complicates tracking. For a country investing heavily in integrated air defenses and long-range missile systems, stealth is the way to create operational surprise. But the flying wing is not a turnkey solution. It demands an industrial base capable of advanced shaping, precision manufacturing, and consistent application of radar-absorbent materials that can survive weather and combat maintenance cycles. It also requires sophisticated flight control software to handle stability without traditional tail surfaces. China's adoption of this architecture therefore signals both a doctrinal choice to rely on surprise and standoff strikes, and a judgment about its own technical maturity. Beijing believes its industry can achieve the tolerances and sustainment practices necessary to make a stealth flying wing operational beyond a handful of prototypes. Stealth works best when an aircraft is treated as an integrated system rather than a sum of parts. The H-20 program reportedly pushed China to modernize its composite manufacturing, refine radar-absorbent coatings, and build new repair regimes for low observable surfaces. In practice, this means developing hangars with controlled environments, skilled maintenance crews trained to preserve signature treatments, and logistics chains that deliver specialized materials to forward basing points. These non-glamorous elements often define whether a stealth fleet can sustain operations. The United States learned this with the B-2. The aircraft's stealth coatings require meticulous upkeep and specialized facilities. For China, scaling from prototypes to an operational bomber fleet will require not just airframe production, but an entire ecosystem, training, supply, and infrastructure that maintains low observability through thousands of flight hours. The industrial investments to reach that point are as significant as the aerodynamic breakthroughs themselves. Despite the promise, the H-20 faces familiar technical hurdles. Engines must be reliable for long loiter times. Stealth materials must be field serviceable. Avionics must operate in contested electromagnetic environments. Integration of large advanced weapons, especially hypersonics, presents thermal, structural, and guidance challenges. Moreover, mass production requires supply chains that can consistently deliver high tolerances and specialized composites. Delays, cost overruns, and iterative design problems are common in such programs. Even the U.S. experience demonstrates that complex stealth systems take decades to mature. For China, overcoming these hurdles is possible. Recent years show rapid progress, but operational maturity across an entire bomber fleet is an incremental process, not a single leap. If the H-20 becomes operational in quantity, it changes the deterrence equation in the Indo-Pacific. Defenders must allocate interceptors, aerial early warning assets, and integrated defenses over larger distances, spreading resources thinner. The bomber adds uncertainty. It can approach from unanticipated directions, carry a mix of weapons, and operate as part of a combined arms campaign that includes missiles and subs. For allies, this creates pressure to deepen interoperability, invest in long-range sensors, and enhance distributed basing options to reduce vulnerability. For China, the bomber offers a platform to translate its growing technological base into strategic influence. Yet deterrence is a two-way street. As H-20s appear, adversaries respond with improved detection, layered defenses, and new operational concepts. The arrival of the bomber thus initiates a cycle of adaptation, counter-adaptation, and the search for equilibrium. Beijing's secrecy means that timelines are estimates, but several indicators are worth watching. Engine testing programs, prototype sightings at remote airfields, satellite imagery of specialized production facilities, and test ranges showing unusual activity all signal progress. Analysts currently project that limited operational capability might emerge in the late 2020s, with fuller production in the 2030s contingent on engine reliability and weapons integration. Observers should watch for signs of serial production lines, the emergence of dedicated maintenance infrastructure for low observable aircraft, and doctrinal publications or training exercises that incorporate long-range bomber missions. Each of these steps would move the H-20 from prototype to operational, instrument and prompt corresponding policy responses from neighbors and allies. The H-20 is not a magic bullet that instantly rewrites global balance. It is a complex technology embedded in strategy, industry, and politics. If successful, it will extend Chinese reach, complicate defense planning for adversaries, and become a central instrument in Beijing's coercive toolkit. If flawed, it may remain an emblem of ambition rather than a fleet asset. The larger lesson is timeless. New military technologies rarely produce simple outcomes. They produce waves of adaptation, new doctrines, and fresh bargaining between nations. The H-20 will do the same. It will force investments in sensors and bases, alter calculations about sanctuary and response, and become one more variable in the volatile interactions of great powers. Watching how China, the United States, and regional states adapt will tell us more about the bomber's real impact than the aircraft's silhouette ever could. If this exploration helped you understand why the H-20 matters, subscribe for more deep dives into the weapons, doctrines, and technologies shaping global security. Tell us in the comments which part you want next: a technical teardown of the H-20's stealth coatings, a timeline of prototype sightings, or a scenario analysis of how the bomber would be used in a crisis. Like, share, and hit the bell so you don't miss the next episode. The 21st century strategic balance will be written in metal and software, and in how nations respond to each other's leaps.